Hi, everyone, and welcome to today's session. So today we're going to talk about something really cool. So you can see this is AutoGen. AutoGen is a framework that is released by Microsoft that basically does multi-agent interactions. So you can take a look here. You can actually program your own agents. You can ask the agents to interface with different functions. You can get the agents to reply in a custom way to other agents and so on. And you can have agents interacting in a group setting as well. So not just one-to-one, but in a group setting. So let's just see what are the features, some very, very basic features of AutoGen. As you can see, there's like 20,000 stars here. That's amazing. There's a lot of people using this. So this is a sample notebook I've compiled using some well-known examples from their notebook section of the AutoGen. You can take a look at this notebook. So first up, just do very, very simple things, okay? So the first thing I'm going to do is to ask AutoGen to like maybe give me 3 benefits of itself. So in order to use, you have to define this config list, and you can actually define more than one large language model here. And if the first model fails, it will go to the second model and so on. But here we just use one model, all right? Because ChatGPT generally works okay. All right, so let's run this. What I basically do is I have an assistant agent and a user proxy agent. So how this works later, I'll explain more in the slides. The user proxy agent is usually the user, like you yourself. By right, you are supposed to run your own code and everything. Okay, but you can actually create an agent to run the code for you. So that's why it's a user proxy. It mimics you. All right. So you can actually execute code using the user proxy agent. All right. Assistant agent typically doesn't execute the code, but you can also interface it with a reply function. You can basically register a reply function so that the assistant agent can also execute code if you would like to. All right. So these are the two main kind of classes that AutoGen has. There's also a third kind, which is the manager class. Later, I'll explain that as well in the slides. So over here, how we do is very simple. We just define our agents. Okay, you can also add in stuff like system message and so on if you like to. Okay, to like edit the behavior of these agents. Okay, but the main thing is after you define the agent, what you do is, you need to initiate the chat. Okay, so one agent will need to initiate a chat with another agent. So in this case, the user initiates a chat with this assistant. So this is something similar to like how you talk to ChatGPT. You as the user talks to the ChatGPT interface, okay, and the assistant will then give you a reply, and then you can continue and so on. All right. So let's see. All right, give me 3 benefits of AutoGen. I'm going to run this, and then you can see over here, AutoGen is a powerful tool that can be used. All right. So you can even ask it to do something else, like maybe give me 3 benefits of multi-agent systems. Okay, and then we can see like, is it generating? Okay, hang on for a while. Yeah, so you can see over here is collaboration, coordination, and so on. So this simple code here mimics like a ChatGPT interface. All right. I mean, it does nothing fanciful. You can also do coding here. Okay, but I leave the coding to the next showcase. Okay, so this one is just like how you would talk to ChatGPT. So let's just exit. So now this is the key agent that I want to show you. This is the agent that can generate charts and images and so on in line in the Python interface. So I quite like this implementation. So basically the code will be executed in IPython and you can see the display straight away. So for example, I want to plot a chart of y equals to x squared. So let's take a look. All right. So in this case, we have the IPython user proxy agent. All right. In this case, we don't have any human input. We just execute this and see the answer. Okay, but if you want to put your human input, you can put here always or something. All right. So over here, you can see that as long as something has terminated, we will end the conversation. So the agents here for AutoGen have been programmed to output terminate when they are done with whatever task they are assigned with. So you can use this terminate word as a cue to stop the conversation. So let's see how this works. Okay, plot a chart of y equals to x squared. So let's take a look. And you can see first, I as the user, okay, the user agent, which is like the proxy for me, all right, will say, hey, plot a chart of y equals to x squared, all right? And then there's also another additional system message. If you suggest code, the code will be executed in IPython, all right? Because the default behavior is execute on the shell terminal. So we want to see how the code is done, so we want to see it on the IPython screen. So the assistant will then reply, okay, saying, hey, to plot, you can use the matplotlib. Here's the code to run it. So this is the code, okay? So it gives you the matplotlib code. So it's quite cool because like if you ever need to generate charts or anything using matplotlib, you no longer need to code this yourself. You can just run AutoGen, ask it to generate code for you, and then you can basically execute the code. If you register a reply function, you can run the code. Okay, after the code has been generated, basically the reply function will just check, hey, is there a code block inside? If yes, if there's a code block, run the code. Okay, so this is quite cool. So you see, now there's a code block. The agent itself, the assistant agent says, hey, there's a code. I'm going to run it. So I'm going to execute the code block, and ta-da, here we go. We have the chart coming out. All right, and you can see that we basically have executed the code using the IPython agent, and the assistant, after getting the output from the IPython agent, says, hey, good, there's no errors. All right, if you need further assistance, feel free to ask. And so the assistant says terminate, and we end the conversation. So in this case, you can also include other agents, like in the slides later, we'll see you can include other agents like the critic, the engineer, or so on to fix code. So you can actually have the multi-agent setting like correct its own code. All right, right now this one is a little limited because in a 2-agent setting like this, if you need to correct the code, you can just put inside here. If the code is there's errors, please fix it yourself. You can do that as well in 1 agent. Okay, so this is what the showcase is for like a code executing agent. Yes, Derek, you raise your hand.
Yes, sir. I just want to ask, I'm not sure if this is a question for you or perhaps our presenter later on, but is it possible to hook up agents from multiple LLMs and define that in the code, or is that beyond the scope of the library? I'm not sure if that's for you.
If possible. So like, for example, you see here, this config list, each agent comes with a config list like here. So you can actually define, okay, apart from like the user proxy agent, I also think you can put the config list, okay? So you can actually have separate config lists for each agent. So like one agent you can use open source, one agent you can use GPTs, and so on. Yeah, you don't have to use the same set of LLMs for all the agents. Yeah, I hope that answered the question.
Yes, sir, it does. Thank you. It's pretty cool.
So this config list is basically what kind of you can even set more than one LM to answer the question, as what I mentioned just now. All right, so this is AutoGen. So this is the native like code running capabilities, and you can see it's quite cool. You can actually run the code. What they will do is they will see this code block, extract out the code block using regex, run the code, and this can be all part of a conversation. All right. So how about group chat? Okay, so 2 agents, just like in a normal society, let's say I talk one-on-one with you, sometimes maybe we lack the relevant expertise to solve a problem. So why not bring in more people in the conversation so that we can talk to one another? So here we have a user proxy agent. So basically it's to mimic me as well. So I, in this case, will be the admin, okay? And basically this guy would coordinate the okay, so this admin will basically say that like, hey, whether or not like I have done everything correctly. So it's basically just to check whether the agent is all the agents have done their role. So we have a coder agent, which is an assistant agent that will generate code. Okay, here this product manager, okay, is to basically like if you want to generate like some product, you can actually have this kind of thing. But over here you can also do other stuff. So in order to flexibly name your agent, it's quite simple. You just put your name, and based on this name, you can actually the behavior can be inferred from the name. All right, but if you want to ensure that like you can generate something, you can also put a system message. Okay, over here the product manager. Okay, maybe I forgot to change it. Actually, it should be something else because like the message itself is just about finding a latest paper on archive. All right, so you can see how this works here. So we have a coder agent, a product manager agent, and then we can set up a group chat. It's like just like how you would do a Zoom chat or what. You have all your agents together. You have my user proxy agent, which is like to mimic myself. All right, you have a coder agent, okay, and you have a product manager here. So all these 3 can be all in the same agent. Okay, you can define what's the previous message history and so on if you want to. But in general, you can have this. You can set the number of rounds. And what we do, okay, this is quite interesting because they did not have a separate like interface for group chat. Okay, the group chat is actually an agent also. So the group chat agent just has another register function in order to run the chat conversation. Okay, but the group chat itself is actually an agent. All right, so in this case, we define a group chat with this agent here. All right, and what we'll do is we will basically run this manager agent. Okay, And what we will do is this manager agent will, you see over here, this manager agent is actually an agent itself that you yourself, okay, you can talk to the manager agent, and this will mimic a group chat. So it's essentially like this whole AutoGen framework everything is to do with initiate chat. So like you yourself, an agent will ask another agent for a conversation. But it so happens that this other agent that we ask is a group of agents. So that's how we do group chat for AutoGen. It's a bit convoluted here because they are mixing up the group chat agent with a single agent. So the idea is you can do a group chat with a manager agent. All right, so let's see how this works. Let's run this code, find a latest paper about AutoGen on archive and evaluate its strengths and weaknesses. So we can see here, this is the user itself, okay, and then we would see what happens, okay. So everyone will talk to the chat manager, okay, and this manager will then like blast out the messages to the relevant people in charge. So over here, so product manager in this case, like quite useless for our case. So maybe we should have changed this to something else. So what we'll do is the coder will basically say, so you see it goes a few rounds and then like basically over here, what we do is the manager agent will actually, based on the task at hand or the context at hand, choose a relevant agent to answer. So this is not a turn-based kind of conversation. This is LLM-based selection. So the LLM will actually select an agent first based on its context, based on the message history context, and then the agent will then reply. So at first it selected a product manager, but that didn't really work out. Okay, so yeah, so Ernest, you asked what's auto reply, right? Auto reply is basically like you can register certain functions to the agents, and if certain triggers are met, like if it's from some agent you want to, or it contains certain content, you can reply. Like for instance, if you are a math agent, only when there's math equations then you reply. Yeah, so this auto reply is like that. You can basically set predefined functions that trigger when like certain chats are being sent to this agent. Yeah, so in some sense, if you treat of it like those kind of computer systems where you receive everything, yeah, you only reply selectively. So your auto reply function can reply selected messages. All right, so the group chat agent, you see, all right. So right now what we'll do is eventually the coder agent will come. Okay, so you can see over here, up here, there's a bit of inefficiencies. Okay, I will talk more about this. All right. So the group chat is not perfect. You can see it goes one big loop. You see, even the product manager. So we have an irrelevant guy here, product manager. All right. If we change this to someone relevant, maybe this would be better. So over here we have the coder, and the coder finally says, "Hey, I have this block of code. You can run this code to check the archive, okay, for any relevant papers on AutoGen." All right. So you see, hey, how come the coder is selected again? So you can see there's something inefficient about AutoGen, right? I mean, after the coder is done, we should just run the code, right? The user agent should run the code, all right? But it went back to the coder again. All right. I'm not here to slam AutoGen, but I'm just saying that there's some inefficiencies here. So you see, already done already. We can just run the code, but why do we go back to the chat again with the coder, right? So in order to curb these inefficiencies, actually AutoGen has this thing called a max conversation limit. So like a single agent can only say at most X number of times so that you move on to other agents. Okay, so over here you can see that we executed the code. Okay, we got this chunk of HTML back. And then what we can do is we can, based on this HTML, we can already extract out the relevant information. Okay, and over here you see the coder is the one doing this. Okay, so maybe if we had changed one of the agents to like be an analyst, then the analyst could do this job. Okay, so this is a second limitation of AutoGen. The agents are very, very similar, all right? Because, although you might define them with specific roles, okay, the specific roles are system prompts. Okay, unless you add in specific tools to each agent, then they'll be different. Okay, so this is the naive version. If you put in tools and stuff like that, you might differentiate the agents better. But right now in this implementation, the coder, the product manager, all about the same. Okay, that's why you see the coder is the one also giving the strengths and weaknesses. All right. So you can see that in the end, that's all. and we terminate the group chat. So, but you see we got the strengths and weaknesses here. We can see that this whole idea of generating code, executing code, evaluating the code sort of works. All right. I mean, let's just take a look because I'm also curious. okay, if we just change this product manager to something else, maybe like analysts, okay, analyze strengths and weaknesses of a paper. Okay, let's just try to do this. Okay, live coding, I haven't tried this before. Let's see whether this works. So what we do is we find the paper on AutoGen or archive, okay, and let's see whether this works or not. Okay, so in the more advanced version of this, you can also add in tools. You can add in retrieval augmented generation, basically to search databases and so on. You can add in other functions like calculator and so on to each of these agents itself. And then you put them in the group chat and see what happens. So yes, the coder says, okay, I will find this. This is the code to run. Okay, great. The analyst will say that, okay, now, you see, now that I named it as analyst, the AutoGen chooses the analyst now to analyze the strengths and weaknesses. Look at that. And then that's it. And then how come the coder responds here again? See, so there's some inefficiencies here as well, right? So I'm sorry, blah, blah, blah. See? Do you all notice something? Anyone can tell me what is the most common utterance of the agent here based on ChatGPT? What is the most common word you see right here? Anyone? Apologize. Yes, Ernest. Okay, you know why apologize comes out? All right, because of RLHF, reinforcement learning from human feedback. Like we want the ChatGPT agent to, to apologize so that it sounds nicer for humans, right? So in the end, you see, what happens is that we have a chain of apologies or chain of thank you. This is something that is quite common in ChatGPT. So let's improve this even more. Okay, this coder just keeps butting into the conversation at the wrong times. Okay, let's see whether we can improve this. So let's do something. Okay, we change the system message here. So because the system message will appear when the group chat selects the agent. Okay, let's see whether we can create code to extract a paper from archive. Okay, so let's make it very specific and see whether, in this case, the coding agent or the coder, it's better managed. Okay, because we don't want the coder to keep coming in. You see, it wastes bandwidth. So you see, certainly now straight away the coder knows what to do, okay, because you have given it as a prompt over here. All right, so the name here matters and the system message matters because all this will go into the system prompt of the agent, and all this will define its behavior, okay, based on the language itself. And also when we have the group chat here, the manager will also use all these names and messages to select what goes next. So you see coder is here and the analyst straight away come in. Okay, I can analyze the strengths and weaknesses of the paper like that. And then, oh, there's something wrong. Okay, there's a code block. Oh no, then the coder will say, okay, apologies. It seems like the code couldn't extract the paper details. Let's give you the updated code. All right. And then, the coder comes in again. So it's still not that efficient, all right? So you see, there's a problem, there's a problem, there's a problem. Oh, looks like now we have a problem. Okay, we don't have this library here, and they are not able to get the code out. So that's this a problem that you could have because something went wrong. All right. So let's create another agent. All right. Let's create another agent. Live creating of another agent. Let's create an engineer now. Okay. So okay, fixes problems with code. Okay, and then we just add in this agent over here as an engineer here. All right, let's see whether this solves the problem because just now there's an error of the code. It keeps generating and generating, but it didn't. Okay, so certainly the coder says, certainly, let's do it. This is the code. Analyst says, okay, these are the strengths and weaknesses. Okay, actually over here, we don't really need this anymore, right? Because, oh, so it seems like these strengths and weaknesses didn't come from the paper. These are hallucinations. Look at that, right? Yeah, I'm not able to execute the code provided. Okay, they have some problem with the code. Okay, eventually the code runs. Okay, so did the engineer fix it? Yes, the engineer fixed it. All right, thank goodness. Okay, I hope people here are engineers. Who here are engineers? Okay, engineers fix problems, right? So if you type in the name engineer, you see the agent fixed the problem, all right? And then over here we have the analysts who say, yes, okay, this is the great thing of the paper. Right, there's something I don't quite like about this. You see, in the end, you're welcome. Thank you. Thank you. Thank you. All very polite. So there's something I don't like about this implementation right now. And what's the thing? the thing is that if you look over here, the analyst actually gave the strengths and weaknesses of a fake paper. All right, because we haven't run the code, we haven't extracted the paper yet. All right. Okay, Ben, you asked for AutoGen is the inner working of the assistant agent taking the arguments and passing it on top of an AutoGen template. Yes, so the taking the arguments and passing it on top of. Okay, so the inner working of the assistant agent basically is just the same as the agent class. There's a send, there's a reply, there's a receive function. I'll cover this in the slides later. Okay, so anyway, there's a lot of things that we could do, but I would like to continue with this. Okay, it took longer than expected. You can see that over here, right now, this analyst over here gave a fake response. Okay, you can actually make this better if you just change your system message here. You can just say only get papers, only analyze the paper after the system, after a code has been run. So maybe if we prompt it like that, we can actually get the analyst not to hallucinate. So the code run first, the coder will do the code, engineer would have these issues to address. Okay, all right. Okay, so let's see what's next. Okay, the analyst. Oh, okay, so there's still a problem here. Okay, so enough playing around with this. Oh, Saka is here. Hi. Yeah, so in order to have the sharing done in time, let's continue with the slides. Okay, so I hope I've just shown you roughly how AutoGen works, and like, because now we will go into some details in the slides. You can see that the native version of AutoGen is not exactly the best. All right, there's some problems. I hope it's apparent based on that demo just now. Yeah, I did some stuff that I haven't tried before today, but you can see some of the potential issues already. So AutoGen, okay, let's start with the presentation proper. I will take about half an hour. Then I will pass on the time to Saka to show a real life demonstration of how to use this for our product. All right, let's start. So imagine this, okay? You want to start with like plot the chart of Meta and Tesla's stock price change, okay? And then the agent, okay, will say, okay, this is the code. The assistant agent will say, this is the code. Okay, then by right, you are supposed to run the code yourself. But as the user proxy agent, you can also set a reply function to say that, hey, if there's a code block, run the code automatically. So yes, I run the code. Oh, there's a problem. Okay, then oops. Then the assistant agent will say, okay, you need to install other modules. Okay, then I run the code to install the modules. And then I run the code to generate the graph based on matplotlib. And when the graph is generated, I can tell the agent like, hey, no, wrong graph. All right, it's supposed to be percentage changed. Okay, so this is the revised code, and this is the graph coming out. Okay, there's a reason why I didn't show this example. Okay, because this example didn't work for me. So as the ChatGPT like evolved over time, what used to work for them as an example workbook didn't work anymore. Okay, so I tried this yesterday. So you can see these are some of the challenges when we do agentic framework. If the LM base changes, you might have the system change as well. So that is also one push to go to open source so you can control your own model. Okay, but that's a separate thing. The idea is you can have this whole automated workflow, like how Iron Man talks to Jarvis, do this, or like help me evaluate the efficiencies of my factories and so on. So you can get all this code generation and so on, all done natively for you. Quite cool, right? That is AutoGen. All right. So what exactly is AutoGen? So an agent typically has 3 functions you can override. All right, the send, the receive, and the generate reply functions. These functions can define its behavior. Okay, but just to let you know, most of the notebooks I see only update this generate reply function. Okay, so this is the key thing that you need to learn if you want to use AutoGen. So there are some things that you can do. So this is the basic agent itself. All right, this is the conversable agent class that that basically takes from the agent class. This basically helps you to do chat in a conversation. So if you want to create an assistant like the OpenAI assistant, you can set human input mode to never. Okay, because you want the AI to take over completely. All right. Code execution config false because you don't want this to execute code. You want to execute code yourself. Okay, then you can define its behavior based on system messages like that. You can also add in tools here. You can also add in tools if you would like to. All right, then as your human agent here, you can set the human input mode to always so that you can always type something in. So you are the agent now. You can respond to whatever the other agents tell you. So you can plug yourself inside this society here and reply to the other agents. Right? Then there's also a third kind of agent that I was talking about just now, a group chat agent. A group chat is actually, I feel like this is a little convoluted because the group chat manager is an agent itself. Well, technically, I rather it to be a structure. Okay, so that like it's a room or something. Then this is like basically this group chat manager should be external to all the agents. It will control the flow of how the agents talk. Okay, but right now this is implemented as an agent. Okay, so what this does is it will direct the flow of the conversation. Okay, so you will say, okay, user proxy agent is your turn. Then after that, when the user proxy agent reply, then assistant agent is your turn, and so on. So you keep doing until the end of the conversation. So if you think of like a moderator for like, if let's say you are going for some events and then there's a panelist and then people talk about a topic, this group chat manager is the moderator. You say, person A would like to talk about your specialty, and person B would like to talk about your specialty. Person A, what do you have to say about person B? Person B, what do you have to say about this? So this group chat manager is the one that says, hey, yeah, it's your turn to speak now. It's your turn to speak now, and so on. So you can also customize the behavior of this, although it is not recommended because they already spend like thousands of lines of codes to configure the behavior of this. Okay. Any questions so far of all these agents? Yeah, so you can see it's quite flexible. You can just basically change the behavior of the agent using the system messages, using the tools that you interface with it, changing the human input mode to always if you like to be part of the agent as well. So these are the template codes, and this is the main thing that you need to know. Okay, so Ernest, you asked, is there a way to see what are the inner workings? Yes, you can go to AutoGen, the GitHub, and take a look yourself. Okay, I will not cover it today because it takes a while, all right? There's quite a lot of lines of codes there. But I will cover the rough idea of what you need to know today. All right, so this is the main thing you need to know, okay? If you want to use AutoGen for anything, register reply is your bread and butter, all right? So to register a reply, you will basically specify which agent you want to take the reply from, and then you can put a reply function here. So it's like, okay, this is your output. Okay, if let's say it's not an input from the human, all right? And if the message includes a code, okay, execute my code. So I can create a code executor as a reply function. So if you want it to have different capabilities, like, you know, if let's say there's a math equation, use a calculator, reply function. If you want it to retrieve extra context, if it doesn't understand stuff, reply function. So basically, if you want additional capabilities, you just put more and more reply functions. All of these reply functions will be active at the same time. So only when a certain trigger is met. So when a trigger is met, that means like from a certain agent or like certain keywords are there. Okay, then run the function. Okay, so you can use it to give the agent capabilities. Yeah, and in fact, the group chat manager, the group chat capability is a reply function. Okay, so that I don't quite like, okay, because it's a bit convoluted. Okay, but that's how AutoGen does it. Okay, the group chat is just an extension of the agent. Okay, so you can see this is how we do it, and then the agents itself will respond to one another. This agent, after receiving a message from the user proxy, will then, based on like its reply function, it will generate a reply and so on until like one side says terminate. Then we end the conversation. Okay. So, or rather, the user needs to say terminate because the user is the main boss over here. Okay, over here you can see when no reply function is registered, a list of default reply functions will be used.
John, any of the agents can say terminate. It'll end the conversation.
Okay, any of them terminate will end, is it?
Yeah. Yep.
Okay, correction to what I said. So any agent terminate. Okay, so the keyword is as long as there's a terminate in the conversation will be ended. Okay, thanks for the correction. Okay, so this is
there's a terminate detection message in the LLM config that determines when the conversation ends based on the terminate.
All right. Yeah, but basically based on my experimentation, is usually the user that says terminate. But yeah, you're right. Any agent that says terminate can end the conversation. Okay, so over here we have a few things. We have the receive function, the generate reply function, and the send function. Okay, so the receive is basically when someone talks to the agent, you can basically change the receive function to change what kind of stuff you want to receive. Okay, generally, I don't really see anyone modify this and this one. So correct me if I'm wrong, Sarkar. So usually people only do the reply functions. Yeah, the receive and send, I rarely see anyone change it. Okay, send is basically like how you send the message that you generated to another agent. So for example, you have this plot, a chart of Meta and Tesla's stock price change. Okay, the assistant agent will receive your message. It will generate a reply. So it's basically like the reply will be like, if it's code, generate a code block and so on, and send the reply to the conversation. Okay, and then after that, the user proxy agent will do the same thing, receive, generate reply, and send. So over here, if you want to give it more functions by adding more custom reply functions over here. So this is how you basically control the workflow of AutoGen and so on. So you keep doing and doing and doing until, you know, until a terminate is. Right. So that's basically how the AutoGen framework works. Okay, for two agents as well for multi agents, or about the same. All right. So it's quite versatile. It can do a lot of things. It can do like math problem solving, although I wouldn't trust an LLM to do math. Okay, math is not exactly the strong point of LLMs. Okay, retrieval augmented chat. Now, basically like when something needs more data, you can actually ask the agent to request for a rec. Okay, so this is quite cool. Elf chat is basically like you have a grounding agent. I'll cover this later. All right, multi-agent coding, I'll cover this later as well. So you have a red team and a blue team. One does the code, one critiques the code, make sure there's no vulnerabilities. Dynamic group chat is the group manager class that basically selects, we saw a demonstration of that just now on the notebook, selects which agent to go next, right? And of course, you have other stuff like even your chessboard, okay, could be a grounding agent where basically you will tell the players, hey, this is a valid move, this is not a valid move. So you can define like a rule-based check as an agent as well. So this is the key system message for the conversation class. And basically you can see, I just want to show you this here because this is basically what they did to make the conversation agent. It's like nothing fancy, but the main thing is you're a helpful AI agent. Okay, if anything, okay, suggest Python code in a Python coding block. So they basically use coding block in order to give you the code blocks. Okay, and then you use the code to output info you need. So they specify like how to do the task. So it's like you need to collect info, use the code to output. You need to perform some task with code, use the code to perform the task. All right. They added some funny stuff as well. You can solve the task by yourself. I guess they want to make it more efficient. Finish the task smartly. Okay, anyone who has done LM prompting, you know that this kind of prompts probably doesn't work that well, right? I mean, like, because this doesn't really tell the LM what to do, right? Solve the task step by step, okay? Right? Chain of thought, they try to use chain of thought, okay? If a plan is not provided, explain your plan first. So it's trying to prompt it to give steps, all right? Okay, when using code, indicate the type of code in the code block, all right? Don't use a code block if it's not intended to be executed by the agent, all right? And then you can see like you can save a code in the file. If there's an error, fix the error and output the code again. Okay, when you find the answer, verify the answer. So they also did the there's this chain of verification paper. So they tried to do everything. Okay, they tried to do everything in the prompt. Chain of thought. Okay. Code excuse. Okay, I mean there's some paper that use code. You know, so they try to do everything here, and in the end you say terminate. Okay, so I would like to say something about this system message. It's too long. Okay, so basically anyone who use LLMs would know that the limit is token length. And for LLMs that go beyond 2,000 or 3,000 tokens, generally the performance would decrease because it's not able to attend to that many messages. Okay, this system message is too long. So this might be the cause of a lot of failures of AutoGen. I mean, if I wanted to, I would just summarize it into like 2 or 3 sentences. Okay, in fact, I have this framework called the strict JSON that basically output stuff as JSON. And one of the output fields could be code block. So you don't have to do all this like write code in this format. You can just export everything as a JSON and then you can just run the code. Okay, so this is essentially what they did, the code as part of the conversation, and basically you use regex to get the code block out. This is also what is used in App Agent. I covered that 2 weeks ago. App Agent also basically has the code sorry, app agent didn't use the code. App agent has different fields like thoughts, action, observation, or in free form text, and it use regex. Okay, but actually, if you just put all in JSON, it will be more concise, and you will ensure that you get that field there as well. So this is something that I think AutoGen could be improved purely based on this system message alone. All right. Let's see. There's some chat over here. Let's Ernest, you ask, is the common system message appended by the user defined system message or overridden? So if let's say you define your own system message, okay, I believe it will override this one. So again, Sarkar, you can correct me if I'm wrong, but I think the system message will override this.
It's overridden. Yep, it's overridden. Yeah.
Okay, thanks. Ben, you asked, this was actually the part I wanted to clarify. Then will you say it would be better to override the base prompt to be succinct? Yeah, I would say that you should override. So I don't think this is the best prompt. Okay, but it works well enough, so people use it. It's just like LangChain. LangChain has a lot of very lengthy and wordy prompts. I don't like any of them at all, but people use it because it's a good starter kit, right? So this is too long, okay? In my opinion, this is really too long, right? 2 or 3 sentences is more or less enough for your system message for this. Okay, but it gets the job done, all right? It does the stuff in the coding block and you can run the code. Okay, let's take a look at the next one. All right, some applications of how AutoGen can be used. So you can actually, in the system prompt, say that if you don't have enough information, reply, update context. So let's say this is the context is this, on January this, who carried the USA flag? All right, the Astros beat the Yankees that night. It's like, you know, wrong, right? This nothing to do with the USA flag. So then the user proxy agent can say, you know, nothing. There's nothing there that can answer the question for me. All right, use update context. And then so we go back to the assistant agent. The assistant agent will go and do some retrieval augmented generation here to basically like supplement the context. And then you update the relevant context here. And then the user can answer the question. Well done. So this is automatic retrieval augmented generation using an agent as a way to say that the user proxy agent will be like the filter, saying that, you know, is the retrieve context relevant or not? If it's not relevant, then you tell the assistant agent, hey, wrong, bro, you got it wrong. Your context is wrong. Go update your context. And then the agent will say, no worries, bro. I'll check it for you. Okay, I'll check my database for you, give you another one, and then I give it back to the user proxy, and the user proxy will say, very good, I got my answer now. So you can see this multi-agent conversation, or in this case, this 2-agent conversation between the assistant and the user sort of gives some form of check and balance, because the user can check the assistant, and the assistant can give the relevant information as well. So there's some benefits to having a conversation style in this case, because a lot of papers have shown, you know, chain of thought, you can plan the steps out. This planner can also be an agent to make the whole thing more concise. Sorry, not more concise, can plan long-term stuff. You can also do reflection as an agent. So by just conversing with one another, you actually reflect on your previous messages, and then, you know, if you have an error checking agent and so on, or the default behavior of these agents, if you prompt it with the right system prompt, you can use it to check for some errors, check for harmful output, check for lots of different stuff. So there are benefits to this multi-agent architecture, but the limits will be how well the LLM can check. Okay, so if you use LLMs, you realize it doesn't check everything properly. All right, it's basically next token generation, and sometimes it fails to pick up certain stuff. So be very careful when you use this kind of check and balance with large language models. But in short, like finding out whether the information is relevant, I think that's a great use, because large language models are quite good with semantic matching, and this is a case of semantic matching. All right, grounding in environment. Okay, that's the second use case I'm going to talk about. So there's this world called ALF world, ALFWORLD. Okay, so this is something that is quite cool because it's an RPG game, a role-playing game. That's purely text-based. Like you are in the middle of a room. Okay, looking around you, you see a bed, a desk, another desk, a safe, a drawer, another drawer, and so on. So your task is to look at the bowl under the desk lamp. So it's like, I need to find the bowl. So I need to go find the desk lamp. So where's the desk lamp first? So you need to go to the desk, right? Yeah, and so on. So this is not that obvious, okay? Because you need to relate desk lamp to desk, and then you need to go under the desk. So there's different actions you can do. And yeah, if you just use a naive two agent method like that, okay, it fails because LLMs tend to hallucinate a bit. So you need some grounding into the environment. And interestingly, they did this grounding as a grounding agent. And the grounding agent basically says that, you must find and take the object before you can examine it. Okay, because a lot of times the agent finds the object, but it didn't take. Okay, it's just like, because in the LM case, if you find the object, it's like similar to taking it, right? But in this environment, you need to find and you need to take. So this grounding agent helps the executor find and take. Okay, so find and take. Yeah, so this is the idea. All right, the idea is to put this grounding agent in order to remind the agent continuously, you need to find and you need to take the object. So, okay, what's my take on this? Okay, my take on this is something like a reflection or like a hint, guiding step, all right, that basically can help to improve the performance of the agent. Yes, that's good. Efficient? Nah. Imagine you need to keep having a grounding agent to remind you, okay? It's not that great, right? Yeah, so let me give you an example. Let's say you need to do a certain task, and then you have a teacher that keeps saying, remember to find and take. Then you do another task, then the teacher will say, remember to find and take. Then you do another task, remember to find and take. It gets quite annoying, right? But if you could somehow natively put in your system prompt for the agent itself, you don't need this grounding agent, right? So I would say that this grounding agent is an afterthought. I don't think this is a good use case of it. But I mean, they ensure that this grounding agent works for Alpha, it works for chess as well. I give it to them. I don't think this is useful. All right, I don't think this is necessary. All right, Ernest, you asked, I think we need to include certain elements that were useful in the base system message. When we use a grounding agent versus put in the system message? So my answer to that is, if I can put in the system message, I would. I mean, this is just a waste of tokens, right? Because you need to have another agent to remind you what to do. So I don't quite agree with this. There's this thing called the React framework. So it's I think, response and action. Yeah, so basically you have thoughts, actions, observations. So the LM itself, one single LM can reflect on its own action, and it can already do it. So if, let's say, in your system message, you say you must find and take the object, I'm very sure in the thoughts, they will also reflect, I must find and take the object. Okay, you can one agent give the whole sequence of stuff just with one agent. You don't need to have the grounding agent. Okay, but in the paper, they showed that Ben said React is reason and action. Yeah, thanks for reminding me that. Yeah, so the main thing is, they said that this actually performs better than React. So maybe because in the React framework, the system prompt might be too far up. Okay, it might not be refreshed in terms of like what needs to be done. So this grounding agent here could keeps reminding the agent, keeps the priority refresh. So maybe there's some use for this, okay, but it's very lengthy. I mean, I don't like this approach of solving this at all. All right, so one thing is that maybe every time, instead of a grounding agent, maybe every time you could have templatized reply structures. So like, if your environment needs you to do something, set as default system message for each message. Yeah, so instead of having a grounding agent, you could have a way of grounding the reply for each agent. Maybe you add this into every custom reply function for your agent that keeps reminding them to do this. Yeah, then you don't have to have a separate agent here, because the problem with this separate agent is that you are relying on the LM to choose this agent, and you may not choose all the time. So I don't think this is a great approach at all. Yeah, Derek, you raise your hand. Yes, you want to say something?
Yes, sir. I just had a thought. So it's around the subject of efficiency, and we're dealing with an agentic architecture. How practical do you think it would be to, how do you say, incorporate something like CLIN, continually learning language agent, into an AutoGen kind of message system like this? Because you would need a memory basis too to keep track of all the memory in order to incorporate an agent like CLIN into something like this.
I agree. So I also think a continual learning agent is good. However, the context length needs to be managed properly because you don't want to put all your learnings. What maybe you should do is you have a summary to summarize key findings. And then maybe this key findings you limit to 3 or 4 sentences. And yeah, I mean, depends on the use case. And then you can carry over your previous learnings to a new environment. In fact, it will be even better if you have context-dependent learning. So like certain environments, you store different learnings, and this will be triggered by context. Maybe like retrieval augmented generation, you retrieve relevant memories, and then you condense it. Yeah, it's very important to condense your stuff because
Yeah.
LLMs don't do well in long context.
So you're saying like an agent that learns how to like trigger like different functions like retrieval or whatever. It
Yeah, so
definitely
maybe
learns
based
how
on
to
the
do.
new environment, it matches its past memory bank and chooses only those memories that match the environment. Then you condense those into one summarized prompt.
I mean, that's
So
pretty
this,
exciting. Yeah,
this is
because
my
you can
idea of
solve.
context-dependent memory. That haven't been
Yeah,
implemented, but in my agentic framework, it will have something like that. Yeah.
yeah. You can solve the context issue with something like Mamba or like a efficient architecture that they're
Yeah,
working on.
Mamba
So that's
is
pretty
changing the whole architecture though. I'm talking about more of like using the native LM structures.
still, yeah. But it's like you said, like it's useful. You can like go into the what do you call it, the config list, so you could like change the different APIs and connections. So you could probably make something custom for this and then connect it. So, but that's just my thoughts.
Yeah, thanks. Okay, so I have to speed up a bit. If not, Saka will have no time for the thing. All right, so let's move on. The other use case is red teaming and blue teaming. So what we can do is we can have a system of agents, okay? One agent will write code to answer a user question. After that, the commander will say, hey, bodyguard or safeguard, is this code reliable? Is this code executable? Will it cause problems to me? Then this guy will say, hey, there's some issues with the code and so on. If there's any issues, then he'll go back to the commander, and then the commander will say, hey, there's problems, go and solve it. And the writer will solve this code, go back to the commander, and then the commander will ask the safeguard, hey, is this code safe to run? Good to run. Okay, then I'll go back to the commander, and then I will say, yes, okay, I'm going to run my code now. So you can do this separate of processes. So I think this is a very smart move. Separating red and blue team agents is smart, okay, because if both are from the same agent, okay, there can be biases. So what ideally you should do is you should remove all history of generating code for the safeguard agent. Okay, so there's no bias. Okay, so it's like a fresh pair of eyes to take a look at it. If you use the same agent to do that, maybe the same agent is biased. And yeah, I mean, you can also refresh the history for the same agent and do the red teaming as well. So there are different ways to do this, but the idea is a fresh pair of eyes to look at the code. Okay, but there's one problem with this approach. Okay, the limits of the writer safeguard is still LLM dependent. I mean, no matter how much conversation you want to add in, if your LLM cannot generate the code or if your LLM cannot find the errors and solve the errors, no amount of system engineering like that can solve it. Okay, so but the idea of splitting into one red team and one blue team, I think that's a nice idea. All right, advanced topics. So in a conversation, usually only one person speaks. Okay, how do we know who to speak? And how do we know when to skip the agent? That's a very interesting question because in a real world example, like I'm giving this talk right now, how do you know who to speak? Like you raise your hand, right, to say that, yes, your turn to speak. But in a more informal group setting, right, like you are in a project group, how do you know whose turn to go next? Okay, so they have done this using this group manager agent, okay, which I don't like the approach at all because I think this should be a template, not an agent. Okay, the group manager agent will basically, based on the context, select the next speaker to go. Okay, there's also this turn-based method, which you can select deterministically. You go through like, okay, agent 1, your turn, agent 2, your turn, agent 3, your turn, and keep going again, then agent 1, agent 2, agent 3, until terminate is done. Okay, or it could be like try to do a smart way by selecting based on the context and based on each of the agent's description, who should go next. Okay, so let's say the manager has selected, okay, the manager will basically ask the speaker to respond. Let's say he has selected Bob. Okay, Bob will respond to the manager, and then the manager will then, based on like the response function or so on, send to, okay, but default behavior is to send to the remaining agents. okay? Or you could custom your sendings to send only to one. Okay, so this is a bit convoluted here because like the manager default behavior is to send to all, but sometimes you only want to send to one agent. And you know, how do you even know who is in the pool, right? So all this are a little difficult to abstract because the original AutoGen, if I'm not wrong, was actually built for only two agents. Okay, and the extension made it a bit clumpy. Right, so I don't like this implementation at all. I think it should be a native multi-agent from the beginning. Each agent should be able to talk to any agent of his own choosing. All right, so this solution right now, we have a manager agent to choose the next agent. I think that works so-so, but as you saw in the demo earlier, it leads to a lot of inefficiencies and so on. I think this can be improved. All right, so this is roughly how it works. Okay, can more agents do better? Let's take a look at the performance. Okay, and they did over 12 tasks, and generally, you know, as what most papers would say, their method works better. All right. So more agents can help. You see, the group chat improves the performance on more tasks, like solve small tasks. You can see like, wow, there's a big jump in GPT-4. GPT-4 plans better. All right. So average number of LM calls for group chat is also decreased, okay, as compared to the two agent method. Right, so interesting. More agents with specialized skills might be able to do better. All right, but there's this task-based selection speaker policy, which is basically asking the group manager to choose who's the next agent, and that performs poorer than even the native two-agent setting. And what this means, it means that if you ask the LM to do selection of the agent, okay, it may bias certain agents, and then you will never select the right agent to do your stuff. Like you saw in the earlier example, I want to get a paper from archive. The analyst just chops in without the code being run. All right, so that's the wrong flow. All right, so the LM may not be able to do this long-term planning that well and selects the wrong agent. So if you do by group chat, like agent 1, agent 2, agent 3, so this group chat is a deterministic flow. If you do by a deterministic flow like that, it selects the agents one by one, and you are assured that your right agent will be selected. So this kind of works better than, you know, asking the LM to choose. So, you know, this kind of shows that, you know, we may not know how to do task-based selection well enough yet. And also, like, you may not have enough, like the context may be a bit too complicated for the LM to choose properly. So this highlights one thing. You need to mix in LMs with determinism for best effect. So you need to combine rule-based plus LMs. So use rules whenever possible so that you mitigate the effects of LMs' poor planning abilities. All right. And also one other thing, don't put too many agents, all right? So a lot of agents here are only 3 or 4. You try with 7 or 8 agents, I can tell you your group chat is going to be like a marketplace, all right? So, and also the message history is just too long for any agent to make a proper move, right? So don't use too many agents. Okay, right now, this is a huge limitation. Okay, we are not there yet for true multi-agent, right? We only maybe 2 or 3 agents still okay. 4 agents may be okay. 5 or 6, I think there'll be problems. Sarkar maybe can share if you have done more than 4. So, yeah.
I've actually done about 6, and yeah, it's not a good idea.
Not a good idea, right? More agents, not that great.
Yeah.
All right, so
Yeah.
this is the idea of like how you can have the critic and engineer correct your code. So I've done something like this just now in the demo. I added in an engineer to update the code. You can also have a critic to say that, hey, you know, the code is wrong, do something. All right. So this is some idea of how multi-agent might actually do the code itself, correction of code. But I think actually if you ask yourself, right, do you really need so many agents to do self-correcting code? Actually, one agent is enough. You just need to do reflection, and yeah, so actually this critic engineer, they are all the same LM, right? You don't need so many rows. You just need one agent do the whole cycle by itself. Then you don't need to keep selecting and routing over all agents. You can have a sequence of processes already defined, okay? And this is something that I think ChatDev did better. ChatDev is the one that generates programs. ChatDev has fixed processes in the waterfall structure. Basically, they go with the idea generation, code generation, and so on. So if you already have the sequence defined, you know, is there a need to go through the whole conversation? So think about that, all right? Think about that. So I think ChatDev actually improved a bit on AutoGen, if you ask me. Okay, because AutoGen too free flow, you know, take a whole year before a decision is made. Okay, maybe not a whole year, but you know, in like a democracy or too many people talking makes too much noise. All right, you don't actually want this to happen. All right. There's this other example that they put in the paper that you can have true multi-agent, a pseudo multi-agent, I call it, a conversation by not selecting all agents at the same time. You can basically do it indirectly because this is not built in the structure. What you can do is you have a generate reply function. Instead of just replying to all, your reply functions can say that, hey, I can reply only to 1 or 2 agents. All right. I think this is a hack, okay, because honestly, this wasn't really designed to work with the main structure. Okay, this is like, this feels more of a hacky way to do it. I don't like it. Right, the other way is the function call, and then you call another agent in your function call. Okay, this actually goes against my idea of multi-agent. Like, a function call should not be another agent. The function call should just be the tool itself. Okay, so if you ask me whether this can do true multi-agent where you can select your other agents, then nah, no, it wasn't meant to deal this way. It's meant to do in a very deterministic turn-by-turn manner. That's more or less AutoGen. You try to do this, I think it will break your system one way or another. All right, try not to do this. Yeah, of course, I haven't done this, but based on this alone, I don't like it already. So, Sarkar, you can give your comments on this if you have any.
So I think if you have a particular agent that only does a particular task, which almost acts like a tool, you can do it. But if you need more fidelity out of your agent, you have to do it. Like if you have one agent that is only, let's say, for example, updating something in an Airtable database or fetching some sort of data from your SQL or from your CRM, that could work. But yeah, apart from that, I wouldn't do it.
Okay, yeah. So that's my sentiments exactly. All right. So this is more like an afterthought. So if you want to do a true multi-agent conversation where each agent can go to different agents asynchronously, we should redo the structure of AutoGen. Okay, AutoGen was not designed to do that. All right. Ernest, you asked a question. Okay, what are the ways we can add determinism to multi-agent? I think the answer to that is you can add it as rules in your function call. So like, for example, if you are doing a chat manager agent, you can set that as a rule, say like, okay, you increase the count by 1 and then go to a different agent each time. And that's exactly what they did for the chat manager agent. They have this deterministic rule inside. And that kind of works most of the time, right? If you take a look at the results that they showed, yeah, the deterministic one works very nice, right? 11 out of 12 tasks, very good success rate. Okay, so this is my main critique of so Asaka, give me another 5 minutes, okay? Sorry, I took a bit of your time, but let me just end off this presentation is that we don't really have this this conversation flow as the best way of doing stuff. Like, a lot of times when you want to get things done, you always talk to everyone involved and then find out the best way of doing things. Then after that, you do the thing in the end. Not really, right? Sometimes you already know what to do. Then you should just do what you need to do. All right. So you look at chat dev. Okay, chat dev is the more efficient version of AutoGen. Right? In order to choose what programming language, okay, look at that. Great, Python is a versatile. Let's get started. You see, look at that. All this redundant language. Right? Actually, all you need to do is like this. I want to create a game. What should I do? Ta-da, done. All right. So this is the JSON framework I'm talking about. I'll be creating an agentic framework based on this soon. So I'll be giving a presentation on that once I'm done. Right? It should take me about 1 month, but I think this will be much better for context. Like this is just too long, right? Conversations are too lengthy, right? And AutoGen takes it to an extreme. You not only have 2 agents, you can have 5 or 6 agents, or imagine the chaos, right? So I'd like you all to think about this. What better way other than conversation? Okay, we can talk about like the things later after Sarkar's presentation, like how to improve AutoGen. Okay, this is my takeaway. AutoGen context length should be short, okay? Because too long a context length, the LM might fail. Not might, will fail, okay? Long context length is not good. Even though you can do like 100,000 tokens, the chances that you will miss a lot of tokens in between. You will lose the context. Modular agents to do different tasks is a good idea, and that's because we reduce the context length. And also, fewer tools equals to more accurate retrieve, more accurate tool use, right? So as far as possible, try to modularize your system. Conversation style is not necessary. If you have fixed templates, fixed structures, is greater than LM base. Okay, if let's say if for a particular task. If you are using a particular task all the time, like retrieval augmented generation, you should just use a fixed way of doing it. Like for example, cosine similarity retrieve, that's a rule-based method. Okay, if you ask LLMs to say, these are the 1,000 sources, find me the 3 most relevant, then it will take quite some time to do it. So if we already know like how to do stuff in rules, like calculator, you want to calculate math stuff, then you can just use the tool itself, or use the fixed structure. Okay, extract out the math block, use calculator, send back. You don't have to say, hey, this is the math engineer, this is the extractor, and so you don't have to define so many agents to do everything. You can just do everything as a single workflow, right? If you already have the template. Right, and one big critique I have is that the code generated is too long, right? You can see it's very lengthy, and I actually ran out of context length for some tasks. So, and there's also a lot of errors, like a lot of errors with importing and so on. So, better grounding could be done. Better grounding with your environment could be done. Like maybe you could tell the AutoGen the list of packages to use. Okay, there's too many errors that come from the coding to be actually reliably used in any commercial system. All right, so the code can be improved for AutoGen. Yeah, Ben, you asked a question. Yep. Sorry, I can't hear you if you are speaking. Oh, okay, I guess you put your hand down already. Yeah, no sound, no sound. Yeah, couldn't hear you. Okay, no worries. You can ask your question later. I'm going to just move on to the live demo by Crit. All right, later on, we will go through some of these questions here, like, is the conversational interface the most efficient? Should the number of agents be flex? Actually, let's maybe okay, yeah. Let me go to Sarkar first. Don't take away your time. Okay, if we have still time after that, we can run through these questions. Okay, so I'm going to stop my share now, and we let the
I'm
expert.
fine with I'm fine if you want to cover that slide. I'm cool with that. Like I have time.
Okay, in that case, shall we just do a quick let's complete that slide so that you can have a
Testing.
reminder of the time. Okay, Ben, I can hear you now.
Okay. Yeah. Sorry. Just a quick question. For coding, right? One thing I realized is that I actually generate a lot of.
Okay, your sound is cut off again. Sorry, maybe you want to type your stuff in the chat instead. I can't really hear you. Yeah, it's still noisy.
Hello. Hello.
Hi, no worries. Maybe you type your question in the chat. We answer that later. Yeah. So this is actually a great illustration of the amount of noise that is present in AutoGen group chat, right? There's a lot of redundant agents talking. Okay, not saying you're redundant, man, but the idea is conversation leads to a lot of noise. So this is a good segue to this question. Is the conversation interface the best for doing multi-agent? So maybe you spend about 1 minute here. Anyone has any views on this?
Kind of depends on the task, honestly. I think conversation is great for a lot of tasks, but it's not required for more linear ones, or like you said, more rule-based ones. You don't need as much conversations.
That's a great response. So based on tasks, if a task is more flexible, reflection-based, then maybe conversation is good. But the task is more routine, then maybe rule-based is good enough. So actually, this leads me to an idea, like, can we templatize into rules from LLMs, right? Then first pass can be LLMs. Subsequent passes could just be rules, right? That might make it more efficient, right? So that could be a
Actually, I think this is actually a very important point. If you can note it down, this can be expanded a lot further into creating learning mechanisms and algorithms from, let's say, group chats or from dynamic chats into more reliable like function calls. This is a very active area of, I guess, research and stuff right now. Pretty good point to note.
Yeah, good to hear that, because actually that's also what I have in mind about learning as well. Like we try not to use the LLM as much as possible because LLMs are slow and also LLMs take a lot of context. So we try to, as far as possible, put things into rules if possible. Yeah. Any other things to add from anyone here?
All I would say is just to reiterate my Clen idea about like making an agent that can utilize a memory-based system and perhaps learn how to learn triggers over time. So you'd have to write out all the rules and be more efficient about the abstraction and rule space.
Nice. I think this is something that should be implemented as well. Active learning agents, right? Which I think people are also trying to do it in AutoGen as well. Sarkar told me about
Derek,
some.
I had a question for Derek. Is that something where you envision that it would retrieve the memory based on certain, let's say, triggers or some sort of like condensed concepts for every interaction?
I think it kind of depends, but yeah, it was basically what you said about like learning the triggers themselves instead of having to manually write out all these triggers, and then it becomes very inefficient in the rule space when you're writing that out for the agents.
That makes sense.
Great. All right, let's move to the next question. So should the number of agents to be 2 or more, or just limited to 2? What are your thoughts for this? So before I give the answer, like what I think in my mind, anyone has any thoughts? Should we just limit to 2 agents, or should we have more than 2 agents?
I think at the end of the day, it is your context length, right?
Yeah. So you're saying based on context length, you choose accordingly, right? Okay, that's one approach based on task, maybe based on context length or like task difficulty. Any other responses for this?
Actually, I think
dynamic
overall,
selection is fine as well. Yeah.
Derek, please continue.
yeah, sorry, no, everyone talking at once. I think overall, actually, it might be way better to just move past the agentic kind of idea and maybe move towards more like expert systems. So the kind of reducing the agent down to an expert and just triggering that expert when something specific needs to be done. So you can kind of have like layers, and this might be like a type of hierarchy system where like you have rules that just trigger specific functions, then you have experts that are like very, very specialized and ultra efficient for inference. And then you have a very complex agent that can trigger and like select different experts for different things. So it's more streamlined and more like natural, fluid, instead of just like, just like an LLM has to figure out how to like trigger all these functions. And like you said, like if you have too many tools, it becomes really bad.
I like your approach a lot, because this means that you can take away the expert from the conversation. Only when like the function matches what the expert is doing, then you trigger the expert to join the conversation. It's something like we are in a group chat and then we suddenly say, hey, I need someone who can design web pages for me. Then I call the web page agent. Yeah, so I think this makes very, very flexible conversations that how I put it, on demand recruitment of expert agents. So this actually helps to reduce the amount of clutter. And once the expert agent is done with the job, you can say bye-bye and kick him out of the group chat. Right? So we could have like a group chat that is flexibly added, a group chat that is flexible with flexible members, and kick members out when they are done. Something like that. I mean, if you do it as a function, it's a one-off recruitment. But sometimes the agent might want to stay a while longer to just make sure that things are done. Then bye-bye, you can leave. Yeah, so we try to minimize the number of agents at one time. Yeah, I like this approach. I also like it better if your expert agent could be like a function call, do the job done, and then that's it. If it can do in one iteration and get the job done, that's the best. Within that one iteration, within the agent, it can do multiple self iterations, but to you it's like a black box. You call this expert agent, done, website design. Yeah, so that could be an approach. Nice ideas, yeah. Any other suggestions for this? Okay, if not, we move to the last one. Okay, due to the lack of time, let's move to the last one. How to carry over the learnings of one agent to another instance. I think we talked about this, some memory. All right, any other suggestions here? So
So one idea that I am playing around with is having some sort of a so when you have like a group chat run execution completed, having some agent analyze that run, extract out the success steps, and then formulating like a function out of those success steps. That is something that could be doable theoretically, but I mean, yeah, it's still pretty experimental, I would say.
no, I like this. This actually is very similar to what I talked about earlier, right? Yeah. So
Yeah, exactly. Yeah.
I do also think of what I talked about earlier, context-dependent memory. So you have a pool of memories for different contexts, and then you extract out relevant ones for new contexts, and then you summarize it. Yeah, so this might actually help it to like learn from a bigger pool of memory, and you can also do in different abstraction spaces, very broad, very specific. And it does do a retrieval augmented generation of the relevant memories when needed. Just take note, just use as little context as possible because context length. All right, Derek, you raise your hand again, is it?
Yeah, I just want to be polite. Yeah, but building off the Clint idea, like you were talking about earlier, it could be really cool to really centralize the memory and then like have all these agents have multiple group chats running at the same time for multiple ideas or whatever, and then have them all dump their what they or like their memory into one single database, and then have that database be properly organized so that any agent can just go into it and pull out any relevant information. So it'd be like really, really fast time. And you won't spend a lot of time like with the bickering or like having multiple memories and like having any issues with like accuracy.
Oh, very nice. Yeah, so I do like this idea of group memory as well, as long as the memory is relevant for all the agents, right? So of course, we shouldn't store memories that other agents that don't really use it. Like for example, if you're a vision agent, you don't need to store memory of like sound because like the vision agent won't use it. Yeah, so I do like this idea of a shared memory for agents that are typically similar and will use it. All right, so actually there's a lot more to go. There's also stuff like, should I do things in parallel? Should I do things sequentially and so on? I think all this we'll discover in the next few iterations of this multi-agent system. I think for now, most things are in sequence because a lot of steps need to be done. Like after you make a decision, then you execute on this decision and so on. You have this broad to specific generation, which you start with the broad goals and then you generate slowly and slowly. This is like chain of thought. So it is typically done in sequence, but sometimes if you know it's split into multiple subparts might be able to do in parallel. So I think this is something that we could explore as well in the multi-agent framework. We don't necessarily need to have only one group chat. We could have multiple group chats or multiple agentic flows at the same time, and then consolidate things at the end. So advanced stuff like that. Okay, Ernest, you mentioned something for having memory self-learning. What you want is tweak the config instead of providing context. Yeah, so we want to put in something like memory into the agents like system message if possible that can be used to ground the agent to do something different each time it's called. Like so it learns from the past interactions. Yeah. Okay, I think we should stop here and Saka, yeah, please feel free to start. So we might end a little late today. We might end about like 12:20 my time. So if you all need to leave, just go ahead. It'll be recorded. But if not, we have like half an hour. Saka, please showcase what you have. I'm actually quite excited to see what you did with AutoGen.
Sure. Yeah, let me share my screen.
Maybe you want to introduce yourself first before you start.
Oh yeah, great. So basically I have been building with AI products since 2020. I was actually in the first batch of OpenAI's GPT-3 closed beta back in August or September of 2020. So I've been building AI products since then with LLMs. This is probably the fourth like large scale product currently with Nomura that I'm building, and I've just seen the entire cycle from the autocomplete Da Vinci, the base Da Vinci, an absolute shit show of a model, but it was really powerful as well. To instruct, to chat, to now GPT-4, and I've had this thing built up where this agentic thing is coming into the ecosystem, right? I was literally on Twitter the day that LangChain introduced the reasoning and action framework. They implemented it from the paper, and then Sam Whitmer used it to create like this web browser back in 2021. It was insane. So it's been super interesting since then. With Nomura right now, what I'm building, it's like trying to have this AI assistant companion sort of thing, like you've seen with Rabbit, with maybe with Tab as well, with Avi is doing, but more on the worker side, the enterprise side, right? Right now, when we're talking about companions and assistants, people are thinking about, okay, I'll book an Uber, or hey, get this table for me, or get my groceries, things like that. But I think when you're actually looking at where we spend most of our cognitive ability on every day, it's on our work, right? It's about making that presentation. It's about doing the research on some prospect, or sending a cold email, or setting up some sort of like a script. So right now, the focus is how do we get these agentic systems to reliably work in a setting where real money can be made, right? With IRL kind of like monetary value. I think that is where we need to head into if we want to have these agentic systems become reliable, because money is the best incentive to get technology to be reliable. And which is why I explored all of these different frameworks. I explored ChatDev, MetaGPT, all of these different things. I explored AutoGen. AutoGen worked quite well for a while, but like you said, there's so many things that are inefficient with it. In fact, let me show you one of the biggest like issues that you'll come across with AutoGen. If you can see my screen, this is my token utilization for this month, 4.5 million tokens. This is my token utilization for last month.
Sorry, did you just say
3.9
4.5 million tokens?
Yes, millions, yes.
Wow.
For GPT-4 Turbo. Okay, so, and this is in like we're in like pre-alpha, right? We don't even have like more than 1 or 2 users. So this is like absurd, right? And this is what you see when you're using group chat, because the problem with group chat is that they're broadcasting the messages to all the agents. So you can imagine the context, the system message plus the context of all the agents are being broadcasted all the time, which is super, super inefficient. And that's why you need that selective routing of the messages. You need that selective, let's say, you even need a way to like intercept messages and only send in parts of the messages to the agents that are like, all agents don't need all the context. We just need part of the context. And especially with John, with your like JSON approach, which I like super believe in, right? I'm like, I'm a total like JSON user. I think even extracting out particular fields and passing only particular fields through is the kind of way we shorten out the context length, we make it more efficient. But as of right now, if you're using group chat, you have to expect this sort of like a utilization. Yeah,
Yeah,
I'll
don't
just
worry.
get into the demo.
I'm sure you like my agentic framework when it's done. You
Yeah,
can try
yeah, I'm super looking forward to it. Yeah, for sure. I have a lot of things that I'm working with the orchestration, but I think this is such an open-ended thing where we're just exploring what's possible, right? Like group chat itself with agents talking to each other in like a non-deterministic way was, I think, a breakthrough. I think it actually was a super, super important milestone, but we have to figure out optimizations on top of that right now. But yeah, I mean, with the more, I'll just give you like at like a base, very simple configuration, what you can achieve reliably. And this does require you to have a decent amount of rate limit as well. So this was on, I think, the tier 3 of the OpenAI usage plan, where I have a rate limit of around 300,000 tokens per minute and about 1.5 million tokens per day. If I try to do it below that, I was constantly hitting the rate limit all the time. So this is after I solved that problem, right? And to give some context about this particular setting, if there is a group chat, actually, let me show you the architecture first. I think that can help them. So this is the general architecture.
Maybe you want to say what this
So-
what this is trying to solve.
Right. So, like I said, an AI companion for work, right? So, you have a lot of tools you're using with work. Let's say your CRM, your Google Drive, your Notion, etc. And there's a lot of information out there that you can have CRUD operations on, as well as need to remember context about for ongoing goals and projects and stuff. The idea is to create this kind of companion that really understands the needs that are in play, as well as what your ongoing aspirations and goals are, and using memory, using these cognitive, let's say, ideas that we've spoken about on the server, right? Using memory soups, using like reflections, chain of thought, etc., to understand, okay, what should the next step be? Okay, what should the next goal be? To make an autonomous kind of like agent. Like one of my biggest problems with agents nowadays is actually calling it an agent, because if you think about what an agent is, the key concept should be agency, right? And right now, they don't have agency. You have to actually initiate an inference for it to do anything. And that's not really agentic. There's no agency involved. Agency comes when even during inference, the agent creates its own goals, right? For the user. I think that is where I'm trying to get to, where the assistant, companion, whatever you want to call it, can set out these goals with broader context about the user, right? And the underlying architecture, I would say, is heavily inspired by two main papers. One is the Koala paper, Cognitive Architectures for Language Agents. That's one. And the Generative Agents paper. These two papers, I think, are super, super important if you want to get into building like these agents, because you really get intuition of how this memory management relevance to different memories work, and how you can pay attention to different like each turn of the conversation. So those two papers essentially created this entire architecture overview. I think AutoGen is just this part that this is the only part that I'm using AutoGen in, which is the execution step, or if you want to call it the decision aspect of the cognitive architecture. The rest, memory and learning, this is your episodic, semantic, procedural memories. John, to your point, where how do we extract learnings from, let's say, ongoing conversations, ongoing tasks? When we do extract learnings, they get added to the procedural side of the memory, which is, I think, where in the human brain, we actually do get our, let's say, skills going, right? The procedural side. So my basic breakdown is this Nomura agent, which is decoupled from the group chat, because when the group chat is running, it's like you can't really do anything on that. So the group chat is to be decoupled from the main agent that the user is talking to. And while this is running, this agent should have context about what's going on out here, as well as all the memory out here. So I've kind of like decoupled it. The main agents are this Nomura agent, where after a particular conversation, number of turns, we do a reflection, we store some facts, we do some learnings from the group chat. Once, let's say I have a critic agent, I have a CRM agent, I have a skill agent, I have a research agent, I've got all of these different agents. I figure out these success traces, I create recipes out of them. I store those recipes in my procedural memory. So that's the kind of like general idea I'm playing with. For the demo, this currently is a planner agent, the CRM agent, the research agent, and the critic agent in the particular demo. And I think the planner agent is the main linchpin of any multi-agent framework, which AutoGen currently lacks. But if you want to look into task keeper, I think that's a good place to start into like how a planner agent can orchestrate the group chat. So
Nice. Let's take a look at the demo then.
Was that?
Let's take a look at the demo.
Yeah, exactly. So, right, let's go out here. Can you guys see this? Can you guys see the text? Okay. So the query of here is get news about Zenrose. Zenrose is a company. Summarize the findings into key insights and add it as a note in my Zenrose record. So I'm implicitly saying add it to the CRM, right? And this is because the Nomura AI agent has context about all the existing tools and resources. So I do this. I'll actually just speed this up a little bit. Okay. Out here, there is a split view of my CRM, and this is the Nomura AI agent is the user proxy in this case. Is giving the instructions, right? And so, okay, what's happening out here? The planner agent is always the first to kick off, and you can see it's all in JSON. The way I've set up the planner agent, and I've made some improvements on this, but in general, I'm trying to spend as much compute as possible to get the plan so that it doesn't hallucinate, right? That's the grounding aspect I'm talking about. So there's an introspection step, there's a reflection step, there is a hypothesis step, and then there's a planning step. So the idea is introspect on the question based on your current grounding and knowledge about your tools and capabilities and limitations. Reflect on how you can make it better, and then form a hypothesis of the plan, and then create the plan itself. And then in the plan, I say, okay, what are the dependencies? So I've got this dependency kind of like parameter as well. And then the speak to agents is kind of like, okay, this agent will do this agent you will do this, etc. So I'm creating instructions for each of these agents out here. And then the speak to Nomura AI agent is actually, okay, this is interesting. If you have a conversational agent and you ask it to do some sort of, let's say inference, right? It will have a tendency to converse back, right? Because it's been RLHF to do that, to do a multi-tone conversation. And I noticed if I didn't have a way to like outlet that, if I didn't have a way to like let it allow it to do that, it would hallucinate quite hard in this step. It would try to add additional things that weren't relevant into this step. It's like it's trying to speak all the time. So I was like, okay, I'll give it a specific parameter so that it can speak. It has that outlet, but I'm not really doing anything with that. Just an interesting
You're
note that I
catching
found.
the redundant output somewhere so that it doesn't
Yeah,
influence.
exactly. Yep, exactly. Because it's always trying to do that. And another way to manage that is with thoughts. Like thoughts, internal monologue is another way to manage that.
Yeah, actually, I would prefer if the thoughts come at the start, because when you generate this kind of stuff, like especially for JSON or sequential generation, it
Yep.
will based on the initial generation to condition the subsequent ones. So if you put the thoughts at the
Yes.
beginning, it can actually help to guide how the rest is
Right.
generated.
Yep. Yeah. In fact, what I like to do, and when I talk to a lot of other founders that are implementing these, let's say, Gen AI strategies these days, they try to use LangChain to make these elaborate chains of the first call will do this, the second call will do this, and they're trying to emulate like chain of thought. And like you can have chain of thought in one single inference with a JSON, right? Because every single field is like its own inference call, right? You can have this step 1, step 2, step 3 in one JSON schema. So that is something I try and like utilize a lot and exploit a lot.
Yeah, this is
So
something I
it's
was mentioning. Like if you were to do this in the group chat framework, you have a reflector agent, you have a
yes, correct.
they have 5 or 6 agents, but actually one single agent with a JSON schema is enough to do everything.
Yes,
Yeah.
yes.
So this is my critic of AutoGen as well. So I see that this is
Yeah.
something that I like a lot, that you did this. You
Mhm.
basically did in the system prompt to ask it to output JSON, right?
Yeah,
Yeah.
exactly. Yeah.
Okay.
There,
Cool.
it's actually a JSON agent. I've added a response type as well. Like, so in AutoGen, there is natively it doesn't support JSON outside the box. You have to uninstall the OpenAI package and then reinstall it and update it to the latest one for it to support the response type for JSON mode basically. But
Nice.
fairly
Don't
simple.
worry, in the strict JSON agent that I'm creating, everything will be
Yeah.
JSON. So this is native.
I'm really excited to actually try that out. Honestly, yeah. So I'll definitely try that out. So yeah, I mean, the web search agent, there's a separate way I'm handling this, but I mean, it's a fairly simple web search like function call. It does a query, and one thing that you guys might find interesting is the query itself, and you will see how it evolves over the course of this conversation. So query number 1 is Zenro's latest news, and then it's executing the web search. So it's a simple like SERP API, and then getting the links and then extracting it, etc. And then it got something, and it's going to get blocked a lot because of anti-bot stuff. So you'll find that it's not getting some of the data, and that is actually causing a lot of issues with the critic agent, where the critic agent is like it's returned 3 results. However, these results vary in their relevance, depth of content provided by Zenros. The first result is directly homepage, which does not provide details. Third result refers to submissions about Zenro's hacker. So it's not very happy with the response from the web search. So it's providing critic. So my critic agent is also JSON, right? It's doing observation, critic, and then feedback. Um, critique and then feedback, and then it's asking it to create like elaborate further. So the next query is Zenro's recent funding news. So it's getting more in depth the query from the web research agent, and now it's trying to get this again. And you'll see there's a lot of failures out here as well. It can't get it, and meanwhile, okay, so while that is happening, while the web research is working out here, the CRM agent got called. The CRM agent got called, and it's searching for the company called Zengo's, whether it exists in the CRM or not. And this is something you'll figure out when you're building agents, is that they'll tend to have a lot of assumptions and they'll tend to hallucinate. Okay, will this work? Will that work? I noticed that if I didn't specifically encode certain logic, it would just assume the company exists or it would create the company. So I literally had to encode this logic, this failsafe that, hey, when you have a query, make sure that you find it in the database. If it's not there, then only you will create that, right? So this is where the rule-based part of it comes into the play, where you have to have these guidelines and guardrails, or else it doesn't have that context. It doesn't know what a proper operation of a CRM should be, right? So I encoded that into the prompt itself. And look, it found that there was no, it found no response searching for Zenros. So now it knows that, okay, Zenros doesn't exist in my CRM, I can create it. And then the critic agent, it got triggered again for some reason. I don't know why, but
Do
that's
you
what
use
happens in the group
the
chat.
deterministic chat flow, or you use the LM-based chat flow?
So this was the LLM based one where the group chat manager auto selects, and that is another problem I have with AutoGen
Yeah. You saw
implementation
in
of group chat.
you saw in the paper also where they did the LM-based selection, it performed poorer actually
Yeah,
than like
yeah,
one.
exactly. I have an improvement on this on my current planner. I will touch on that, but yeah, this is, I mean, and one more thing is if the group chat manager is on 3.5, it will perform a lot worse, and it's going to call agents multiple times. Like literally, I will have a situation where the CRM agent is being called to do a web research. Like so it's 3.5
Yeah.
performs a lot worse on this.
All right. Earlier before you came, I was showing how the like agent can extract the paper from archive, and
Yeah,
the coder agent is asked to do like analysis. So yeah, so it's
yeah,
like
yeah, exactly. Yeah,
the
yeah,
wrong agent for the wrong job.
exactly, exactly. Yeah, 100%. It created. So you can see the function call happened. It created the company, and at the same time, it provided the ID and the details for the company. And the critic agent, again, the critic agent is coming after the CRM agent is doing an operation, which it shouldn't, but group chat, right?
Actually, is there a way to specify only an agent to respond to one particular type of agent?
Yes, yeah. So you can use the request reply function for that, and that will enable the agent to, okay, I only want a response from this agent, or this is the only agent I will respond to. So you
Right.
can
So
define that.
you
But
can
like you said, it's too cumbersome.
artificially set your critic agent to respond
Yeah,
only
yes,
to a certain
yeah,
agent. Then you can avoid this.
correct. Yeah. In fact, there's another way to do this, but the PR never got merged. It's the graph group chat where you can create branching graphs of conversations. So you can have one group chat with like a graph based node. So the planner will come first. It'll provide the let's say the message to one node, which will branch into other nodes. But that PR never got merged. I think the AutoGen team is working on an improvement on that right now.
Nice.
So the critic agent, okay, now the web search agent is again coming, and now the query becomes even more complex, which is Zenro's funding round details and future plan objectives. So this is good, right? The critic agent is actually improving the web search. It's iteratively creating better and better queries. So this is something that we should explore more, and it should happen. So it's again doing the same thing. It got details, but you'll see that the critic agent, a lot of times, it triggers because the web search agent is getting blocked. So when I'm trying to scrape the content, obviously I can't block it. I'm getting an error when I'm trying to scrape it. And the critic agent doesn't understand that this page cannot be scraped and it should stop, right? And I actually made a comment on the server couple of maybe a week or two back, which is adversarial agents can go off the rails. Like the critic agent is an adversarial agent at the end of the day. It's trying to improve the outputs with like adversarial attacks, but it doesn't know when to stop. And that is the problem. It's not like in an RL, you're optimizing for a particular reward, right? But it doesn't get to that point. So I think that's something we need to figure out, like what's the best way out of this. But because as a concept, adversarial improvement is good, but right now there's just no way to create a optimal way for it.
I have a suggestion for this. That
Yeah.
is, you can put your critic as a function call. So it's like, if only when needed by another agent,
Mhm.
you have a sort of a filter that could be LLM based
Yeah.
or something to see whether a critic is
Mhm.
needed. If yes, then you call this critic agent as a function. Yeah,
Right,
so
right.
you have the
Yeah,
critic agent inbuilt to
yeah,
the particular agent that you want the critic
yeah.
for.
Right, right. Yeah, I mean, that's one thing I'm exploring. Another thing that I'm trying to explore is encoding more grounding. So, like, actually making the agents aware that, hey, look, if you're okay, so I'm trying to encode into the agents to expect a certain failure rate. Like, you will fail at this. This is a web search. There are anti-bot technologies out there. You will fail. You will get blocked on certain websites. Expect that sort of a response and have a certain number of tries before you're like, okay, it's not going to get any better. Um, I don't know how well that's going to work over the long term. Right now, in my current iteration, it's okay, but I think your suggestion might also improve that
I
idea.
have
So
another suggestion, all right? And that's to do
yeah,
away with a group chat manager. Like a lot of times in the conversation, actually, there's no need to have a manager. The agent itself
correct.
actually
Yeah,
knows which agent to call. Like, for example, after this website
yeah.
is done, you can
Mhm.
just call the CRM straight away, right?
Yes,
Right.
exactly.
So
I'll
if you
show
give,
you my improvement on the planner on that. Yeah.
oh, okay. Yeah, I mean, I was thinking if you give
Yeah.
the agents like a list of who they are conversing with, they can actually
Yep.
select who
Yep.
is the next target
Yes.
themselves. Yeah.
Yep. Yep. I'll show that to you. I've implemented that actually. Um, so the web search agent returns. Okay, so this query is Zenro's funding impact product development or growth strategy. I really like the interplay between critic and web search flow. You can see the search getting a lot better, right? It started with Zenro's latest news and it ended up out here, which is really, really cool. But
Yeah, but at the same
figuring
time,
out that balance is
you have a lot more tokens.
a lot more tokens, a lot more time. Like you can imagine, right? As a user, I'm waiting for like 5 minutes for this to complete.
Oh, it's 5 minutes for one.
Yeah, yeah, yeah. Yeah, 100%. Zenro's got created, so you can see out here. There's nothing out here and gets created out here. But it gets something, and by this time the critic agent is actually frustrated and it's literally just giving up. I'm not even joking. It's just giving up. And then the node is created. And now you can see that it created this node. So
Nice.
overall, yes, there are hiccups, but this is like it's a magical thing, right? I literally just typed in a query and it did the research, created a note, summarized it into a note, created the record in my CRM, and added that note to the record. This is insane. This is insane. This is an actual value proposition.
What if I told you I can do exactly what you did with just 3 conversations? Like you could just have the tasks, then after you flow the task into
Yes.
like your web search,
Yeah.
then you put
Yep.
into your CRM. So it's like a 1, 2, 3,
Yeah.
3-step workflow
Yeah.
without any conversation.
Yeah. Yeah, this can easily be done in like 3 steps. I think this can be done in like 2 steps, honestly, because some of these tasks that parallelizable, like you don't have to wait on certain interactions. So, for example, creating searching for the company and creating the company, it can happen parallelly, or maybe creating the company and then creating the note object before you append it. You can create parallel steps and make this a lot shorter. So that is something that I'm currently like working on, and what your previous topic that you spoke about, which is like making the agent select the next agent. That is where it comes into the picture as well. So it created it. I'll just quickly show you the updated prompt, right? Let's see.
Nice.
So out here,
Yeah, so this is, I think, in response to Ernest's question, right? He asks, what is the agent prompt to do for JSON reply?
Yeah, sure. So it's basically you just you give it the schema, you just define the schema. One way I would define the schema is you can add this comment after every parameter to explain what that
Take
field
a
is
deep
supposed to
breath.
do. Yeah, yeah.
Yeah, does it work? The take a deep
Oh
breath
yeah,
one?
yeah, yeah.
Like,
Yes, it does. It does. I've tested this. This works. Wait, I think I've even made this a bit 1 second. Yeah, so I've added this as a I think this is a bit too much. Take a deep breath and think step by step together. And I'm planning on adding the what do you call it? The tip. If you perform this correctly, I'll give you $200, and I'll also add in the fact that I have no fingers. So I'm gonna add in all these different tricks of the prompt into this. But this does work. I can say it works.
it's the prompt reader by DeepMind. Yeah. So
Yeah, prompt relay.
yeah, this is something that encourages the LM to think more like critically, because like normally when
Yeah,
humans say take a deep breath, they normally do things in a more detailed way. So they are learning these human biases in these prompts. This is what happens
yeah,
when
exactly.
we don't exactly have a fixed step for them to follow, because if you have a fixed step for them to follow, you don't have to use all these prompts. You could just do a rule-based step
Right,
follower. Yeah, then I
right,
think that will
right,
solve a lot of problems with conversations. But yeah, I mean,
right.
interesting to see what you did. Yeah, interesting.
But okay, so this is like the instruction to the, let's say the plan, the planner prompt. So the instructions access HubSpot, locate the company for this record, and then create this note. So the note is this, right? And the planner will create a response. And I've changed the schema field somewhat, but I'll show you the main point of the field where I think it can improve the group chat.
Actually, I have a feeling your take
Maybe
a deep breath might be causing it to say very long stuff. Yeah,
that could be. This is actually the wrong planner. 1 second.
right. No, not critical. I mean, I'm actually personally more of a fan of short and concise answers. So it would be
Yeah,
better if the JSON could be shrunk even more. Yeah, because the thing is, the longer your output JSON,
yeah,
the more
yeah.
context history you need to feed in the other
Right.
agents.
Right. No, I so I was trading off between context length and accuracy. So I won't say I like to, but it's kind of like I'm forced to right now with the current architecture, which is areas that I can't screw up at all, like the instructions or let's say the planning parameters. I am mm, somewhat more willing to spend more tokens to make sure they come out correctly rather than save tokens and they might hallucinate something. So I don't have that in all my fields. I have it in some fields, which is like, okay, this is an important field. So, take a deep breath, spend some tokens on this. But I am always trying to improve this all the time. For
I
sure.
have one other suggestion for you. Sorry, this is not
Yep.
not a critic session, but just to let
No,
you
no,
know
absolutely. Go
the
ahead.
score part, right? The
Mhm,
rating from 0 to 1, LMs generally
mhm,
perform quite poorly at giving a score, because like if you ask it to rate an
mhm.
essay from 1 to 5, sometimes the same essay is a score
Yeah,
4, sometimes a score 3, sometimes a score 5.
yeah.
It would be better
Mhm,
if you do classification instead. So it's like 3 if the
mhm,
essay is great and meets this criteria, 2 if this criteria, 1 if this
mhm.
criteria. Yeah, so
Right,
so that
right.
that
I've
could be a good.
actually removed that score. Yeah. So this
Yeah.
part where I have this solution score, I've actually removed this.
Mm.
The reason I kept this is not to critique it actually. So I'll run you through the solution score. Considering the given task, the score will provide rating from 0 to 1. You will observe the responses from other agents, and you will provide a score only after all tasks from all agents are complete, based on responses you've received, and determine the score based on how closely it matches the task that you've been assigned. Then the type of response is the final solution. But okay, I think I removed it out here. But the reason I kept the score is actually to print terminate. It wasn't to score the response. It would only print
Uh,
terminate after it was satisfied with it. But because I was seeing it was printing terminate to frequently and too easily. So that is why I kept that score.
I
But
see,
I
I see.
removed it after that. Yeah. But yeah, so the main part is I've added this new part, which is called, it's an instruction object where I have working agent, which is currently a choice, but it should be an array, where it will
You
define, okay,
specify
right now,
the
use the
you
CRM agent.
specify the
Yes,
agent you want next, right?
correct,
Yeah,
correct.
yeah.
Along with the task. So the idea is once this message is generated, you only extract out this field, just this field. And you pass this field as the input to the
Oh, but
agent that's been specified.
your
Okay.
task is still too long.
Oh, no. This is, no, that's because this is the node that has to append.
Okay, then that's fine, that's fine.
Yeah, this is the name.
I actually like
But
one
yeah,
thing that
the
you
idea,
did. You
yeah.
actually, your type, right? Your choice, the type that it
Mm.
must be one of the following types: research report, email, generate summary. I like this part a lot because you constrain the output of the LLMs.
Yes.
So if there's any
Yeah,
prompt engineering guide that I like to share with people, is that constraining the output choice to a few suggestions generally
Yeah.
helps to improve reliability of LLMs. So
Yeah. And
that's
another thing to keep in mind is that when you're transferring, let's say, information between two agents, there is a very high probability it's going to get summarized down the chain, right? Let's say the answer is provided by one agent that goes to another agent. That agent has to give it to another agent. By the time it goes to the final agent, it's probably summarized a little bit. So you want to define things that don't get summarized, or if they want to get summarized, that's why I added a specific type for like general summary. So it doesn't keep summarizing things, right? That's another thing I found out. But yeah, this is something that I think is a good way to improve the group chat. But you don't need a group chat manager, like you said. The planner, it can select the agents.
very good. I mean, you seem to be doing the next generation of AutoGen already. Nice.
I mean, it's a lot of it is like you use AutoGen. It's like, okay, why is it doing it like this? Can I do it something better, right? It's basically what you felt after going through AutoGen. It shows you the possibilities, and then you immediately see what the inefficiencies are, and you can start thinking about the improvements, right? I think a lot of it is just using the uh like the products and the packages, libraries, and seeing what you can make better. But yeah, I think this is the way that you can create a much more what do you call, much more constrained but flexible group chat where, like you said, it's like an off-the-shelf picking of the correct agent, right? It's not all of it is not in the group chat. You just pick the
And
correct agent that is required.
my own preference is that if it can be systemized into a workflow already, you don't have to even choose the agents with an LM. It could already be predefined process that you just run.
Right. And that is, I think, where this recipe learning can come in handy, where you analyze the group chat and you see what's working, what the success cases were. You extract out, okay, step one, CRM agent, step two, function called step three, this agent,
Yeah.
and then you create a function for that.
Maybe we can call it a sequential chain or something. So you don't have to go through group chat. You can just run the chain.
Exactly. Yeah, exactly. Because I'm thinking about it from the perspective of a real world use case, right? Because what did I do in the demo? I said, here's the company, do some research. If it's not there in my CRM, create it, add it as a node. This should be like a repeatable process because if I'm a salesperson, I want to do that to 100 companies. I don't just want to do it to one company. So I can't run the group chat 100 times. That's going to blow my account, right? I want to run it without the group chat and just run it 100 times on my Excel or my CSV and get a list that I can plug into my email automation platform or something. So that's kind of where I'm trying to head into. This couple of challenges is like, let's say you have a recipe chain of, let's say step one, step two, step three, whatever. You have, let's say 5 steps to accomplish this particular task. The challenge is in some of the middle steps, you might need LLM inputs. Like for example, the critic agent maybe needs to provide a better output in step 4, right? Or something like that. Getting those dynamic LLM inputs plugged into, let's say, the middle of the chain, that is something that is going to be a challenge. It's like an adapter in a, let's say, a recipe or something.
Yeah, very nice.
So,
But I think it's a great implementation. Just the AutoGen part is not very efficient. So actually,
I mean, that's
maybe
what we're doing.
in the last 5 minutes or so, you want to share like I mean, because you talked to me before, like you said that AutoGen is what you chose after seeing the rest. Like, what excited you or what enticed you to use AutoGen compared to other frameworks?
Yeah, sure. Yeah, for sure. So I think AutoGen's group chat is actually quite novel. I think it's novel in the sense that it might even be too early for its current time because right now we're so limited by tokens and by latency and stuff. But I think the general concept about having a group chat where multiple agents are interacting, if you can control it, if you have a lot more reliability on it and constraints on it, and it's more grounded and it doesn't hallucinate, I think it's a more realistic way of how humans work, right? Imagine you're in a Slack with your teammates, right? That's what's going on. You have a set of people that are talking to each other in a particular channel. They're creating threads in different parts of the channel, and there's like focused conversations going on in those kind of like threads. And that's how humans work. And I think if we can mimic that, the agents themselves should become a lot more efficient or better in their output quality. um, AutoGen's implementation is essentially like a WhatsApp group chat. I think a better implementation is like a Slack or Discord, right? Where you can have a general like chat where everyone shares the context. You can also have like dedicated channels or dedicated conversation threads. You can have DMs. I think trying to imitate that is not a bad idea. Um, if I will tell you why I didn't choose something like chat dev or MetaGPT or super agent. I don't think linear planning works, or linear steps. I don't think they work in a generalized setting. Yes, it does work in certain like defined tasks and contexts, but when humans are working together in a dynamic setting, right, we need to like, for a lack of a better word, back propagate to a different state. Where
Yeah.
something goes wrong, you have to go back, and that is not possible with the other frameworks. Whereas with AutoGen, since every agent has the context, they can figure out, okay, this is the dead end. Let's go back to a previous, let's say, point where it was working and start from there. So that was one of the main reasons. Also, the fact is, it's even though the code is kind of cumbersome, given the complexity of what's going on, I think it's well written and it offers a lot of customizability and like you're closer to the bare metal of the framework. With other agents, they're a lot more abstracted, but yeah, I mean, it's pros and cons to each. I think the pros outweighed the cons at the time. And right now, after having experimented with it and seeing the ways it can be improved, it's a good idea to kind of like move on, at least for, and I'm guessing for you as well, after one view of it. Yeah.
Nice. Thanks so much for sharing. I learned quite a bit from your implementation, and I look forward to the next generation of the AutoGen. Hopefully, it's my strict JSON framework or a build on of something else.
Yeah, for sure.
Yeah.
Yeah.
Ben, you raise your hand. You want to say something before we conclude?
Yes. Hi. Yeah. So can I just ask if you tried LangChain as well? And so I was playing with LangChain and I realized that or rather I was able to implement a kind of a conversation structure, albeit it is not part of the actual package. So I built it from scratch and it is also able to do that. So I'm just wondering, maybe in your experience, both John and Saka, what kind of propelled you to AutoGen over LangChain? If yeah.
Yeah, maybe
Sure.
Saka answer first. Yeah.
Yeah. So for me, LangChain is too abstracted. It's got its own way of doing things, and I'm not a very big fan of the way it's heading down, like the direction they've chosen. They're choosing a direction which is trying to incorporate everything into their framework and creating their own implementations, integrations, and etc. It's great to get started and prototype. I don't think it's production ready. I don't think you can create a production app like and scale it with LangChain. One like quick example of that is our scraper that you saw in the demo. It's the LangChain scraper. It's their scraping module, and it turns out that we were utilizing way more tokens than it was required, and like our costs were rising a lot, and then we were trying to figure out diagnose especially where the leak was happening, and it came down to the line chain scraper. And when we looked at what the scraper was doing, it's like it didn't have a cutoff point in the amount it was scraping. So for example, if a web page has 100,000 tokens, right, if you are trying to scrape it, it would get all 100,000 tokens and try to summarize it. When it should have some sort of a cutoff point, some sort of like a guardrail or fail safe. And sure, like
Right.
we should have caught it sooner, but it wasn't evident when we were implementing it right off the bat. I think those are certain things that will pop up in LangChain when you're using it. And also you lose a lot of like flexibility when you want to implement other frameworks and other like stuff into the into your product when you're using LangChain. You kind of get forced into this. There are other packages and their utilities, which personally I don't think is a great idea if you want to build a production kind of application.
Right. Thank you so much. Yeah, very clear.
Yeah. So anyway, we have 1 more minute left because I need to go. But let me just share with you my thoughts on LangChain. I don't use it. Yeah, and the reason why I don't use it is because I don't like their prompts. Their prompts are too long, just like
Yeah, the
AutoGen.
prompts are also
Right.
Yeah.
So what I actually do is I override the prompts. I make it a point to override every prompt. And okay, but granted, LangChain is like my first array into this entire thing. So I have not tried AutoGen, but I'm just wondering. LangChain was just my starting out to place, right? So I'm just thinking if I should switch to AutoGen. By hearing this, I think I will give AutoGen a try. I have one last question.
I don't think it's just a quick note. I don't think they're comparative. LangChain is an implementation framework, right? And AutoGen is a multi-agent framework. You can recreate AutoGen with LangChain if you want.
Yes,
I
that's
think
actually what I
the
have been
LangChain's-
doing. Yeah.
In
I
fact, the
just think if
LangChain
you
provides a good suite of tools that you can use.
yes,
Yeah,
correct,
like
yeah.
you can split into chunks and stuff. The text recursive splitter is not bad. Yeah, but if you want to use
Yes.
don't use their prompts. But you can use their tools. Yeah, their tools are not too bad. Like our sub API.
Just be careful. You're not. Just be
Yeah.
careful that you know exactly what you're implementing, so you're not like having the same issue that I had.
My personal
Right.
preference.
Yeah,
is
that's actually the difficult part as well. Yeah.
my personal preference is to recode my own tool myself so I can control it. But that depends
Right.
on what you want to do. If you are just taking a plug and play one, I think LangChain works well for beginners, but I wouldn't
Yeah,
recommend
yeah.
it for advanced use. AutoGen also, I
Right.
wouldn't recommend it for production use. It's just too lengthy. Yeah, we need to make it even more concise and more reliable.
Yep.
Right.
Yeah, I think
But
LangChain is
as
great
of
for
right
beginners
now,
for sure.
there's only those two that are kind of like the main contenders, right? There's not really something else that will be more production ready, right? Is there any apart from the one that you mentioned previously, which was ChatDev?
I'm creating my
I
own string JSON.
Right. Okay.
Yeah, soon it'll be out. Yeah, then you can check it out.
Right. Very
I
interested
mean,
to look forward to it.
just like I'm not very sure why like LangChain is becoming the default. Like they do have a good developer community and stuff, but I don't think it's that difficult to work with the vanilla OpenAI modules and APIs. Is it? It feels fairly straightforward to me. I mean, I think if you build out your own implementations, you'll have much more control over it. Like John is
Right.
saying.
Yep. Okay. Thanks, Sarkar and John. I have one last question if there's a time.
Yeah,
And that is, I'm guessing if I when I try to generate code, I get syntax errors. And no matter how much I try, I can't get it to fix the syntax errors. So I'm talking about things like the extra brackets, the random backslashes.
don't worry, you use strict JSON and it fixes first for you. Yeah, so
Right.
basically the idea of doing that is to basically you need to use something to pass the code so that it removes all these extra backslashes and so on. Extra brackets can't really fix for you because that one means your code generated wrongly. Yeah.
Yeah,
but
and any idea how to fix that? Because yeah, I have some form of JSON parsing. I mean I'm not using strict JSON as of right now. So I do have JSON parsing, but the problem is that the code generated is wrong, but only in the syntax error. Like the rest of the code, I look at it and it looks fine, but the syntax error, I'm not sure. Do you have any approaches to fix this like extra bracket where like there's 2 starting brackets and there's 3 ending brackets and then there's a syntax error. And
I
any
mean,
idea what
one
causes
way
this
is to just pass the entire code and ask LM to correct itself. It can do that sometimes. The other way is maybe you just need to give it like some example code or something so that it doesn't repeat. that what model are you using to generate this code?
Right now I'm using Gemini Pro. Simply because it's free.
That's the problem, you see. You are using Gemini. So Gemini is not as great as code as ChatGPT. So
Right,
you know,
right.
You can also
this-
try some of the open source code models like Wizard Coder and stuff. I think
I'm
those
trying
would
Code
also work
Llama
quite
right
well.
now. So yeah, we'll keep the group chat updated if I manage
Mhm.
to fix those
Right.
errors with Code
Yeah,
Llama.
actually, for open source models, code it can be a problem. And so for this, even if you ask the LM to correct its own error, it may not correct it because it just doesn't know how to. So this
Yeah,
one,
yeah, that's kind of the issue.
correct. This one, I think if you really want something to correct externally without the LM, you can try to match brackets and so on, but you might get the code wrong. So it's
Right.
better to use a better model in this case for code.
Okay.
Then
can.
you could try to just use GPT-4 for the correction, and the rest of it you can still do it in Gemini. So once you get the error, you can pass it into GPT-4 and have it corrected for you.
Okay, I can try to explore that, cause cost is a concern lah. for me, for me.
Yeah, I mean,
Because I'm not using
that's
this
going to
for
happen
commercial
very
purpose yet.
rarely, right? So
Actually, for syntax,
that would happen very rarely, though.
for syntax, ChatGPT is enough. The GPT 3.5 Turbo is good
Oh,
enough for
3.5.
syntax
Okay.
is good enough. Yeah.
Okay,
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 I
okay.
think we have to end here. So if you have, I think it was a great session on AutoGen. It showed us the capabilities and the limitations of what AutoGen can do. And yeah, I look forward to seeing your implementations if there's any. And yeah, do check it. Do watch out for my agentic framework coming out soon. Coding it right now.
Can't wait for it.
Yep. So that's all for today. And yeah, thanks for coming. See you around. Bye, everyone.
Thanks, John.
Yes.
Thanks, Saka.
Thanks, Saka, for presenting as well. Okay. Bye.
Appreciate it. See you guys.